Okay, welcome you all. In this video we will see how we can generate and visualize a Sinc function in MATLAB. So Sinc function can be described mathematically as sin pi t divided by pi times of t in a continuous time, and in a discrete time it can be mathematically represented as sin pi times of n divided by pi times of n, right? So actually in MATLAB offers a separate command called Sinc function. So using straight away Sinc function we can build the signal, or by means of a standard mathematical formula like sin c t equal to sin pi t divided by pi t. So using this general formula also we can build a signal. So I go with making a Sinc function from the fundamental formula, right? So let's create a file first. So as we know, we have to first save the file, and then we have to create a x-axis variable. So let's name this file as Sinc signal, right? So I just use the same x-axis data from my previous example. So let's keep this. Right, so I consider my time scale as -10 to +10. With each time it is going to increment by 0.001, and I am considering my samples from -10 to 10, right? Okay, just rename this figure as Sinc, right? Sinc signal. Okay, so now we have to create a amplitude. So let's name that amplitude as y1 equal to sin ct can be represented as sin pi times of t divided by pi times of t in a continuous time. So let's type sin pi times of t, which is nothing but 3.14 times of t, right, divided by pi times of t. So open bracket, 3.14 times of t. Actually here I wish to find out the magnitude for each time step, right? So we have to take for all the time step t, we should calculate this. So for that we should go with the each time step division. So for that we should actually use dot divide. So this will perform operation for all the time step. Okay, this is called as actually a we say bitwise division. So for each of the t data this operation will be performed, right? If I am not putting this dot symbol, then it will take the amplitude only for the final t, right? So I wish to take the amplitude for all the time steps. So for that I should go with the each time t. So for that I am putting dot and division operation. Okay, right. So now we made an amplitude. Now I go for a plot x-axis, then y-axis data, right? So this is going to make a Sinc function a continuous time. So now I just label the x-axis, y-axis, and also I'm going to keep the title of the plot. So just rename this as Sinc signal in continuous time. Now I just try to create a Sinc signal in a discrete time. So for that first I should create a subplot. So I'm going to place a Sinc function in a continuous time in the position 2. So I'm keeping 2, 1, 2. So now I have to make a amplitude. So let's keep the amplitude of a Sinc function in a continuous in a discrete time as y2, which is equal to sin pi. You can actually type pi also straight away because it is already declared as a 3.14 in a MATLAB. Sin pi into n, right? Then dot and division. This, as I said, it is going to do the operation for each of the n, right? Bracket pi times of n. Done. So now we made a amplitude also. So now we go for making a plot. So for making a discrete plot we should use a command called stem. So x-axis data, which is n, followed by y-axis, which is y2. Okay, so now I just label the x-axis and y-axis. x-axis is actually samples. Y-axis we can keep amplitude, and the title I'm going to keep sin C signal in a discrete time, right? That's it. Just run this code. Now you can see this is what sin C signal in a continuous time. This is a sin C signal in a discrete time. You can see the amplitude change here, right? Initial the amplitude will be about 4 times of 10 power minus 17. This is minus 4 times of 10 power minus 17. Maybe to make better visualization, so we just try to rescale this. Alright, so now you see the signal magnitude is here very small. So to see the sin C signal in a discrete time in a proper way, I just try to change this value, the rest compress this n by just keeping here as instead of n I'm just going to put the n by 2, right? So let's change this to n by 2. Save and run this. Now you can see we can able to visualize the sin C signal in a proper way, right? Thank you.